Okay, example 4. A car was purchased for $24,000. Function y equals 24 times 0.8 to the x power. Notice the structure here. Again, they're using some different notations of the y and the x instead of a sub t and t, but it's the same facts as before. We have some number to a power being multiplied by a number equals something, right? So it's the same basic structure as an exponential function. And they ask us several things. First question, it says, this is modeling the car, the value of the car in thousands of dollars, X years after it was purchased. They didn't tell us what year it was purchased, but the number of years after purchase is what X represents. Y is going to be the value of the car in thousands of dollars. So if Y is equal to 10, that's 10,000. If Y is equal to 9, that's 9,000. Right now, at year 0, Y equals 24, which is 24,000 what it cost when we bought it. Okay? So first question says, does this function represent exponential growth or decay? The place I look to answer that question is right here. What's being raised to a power? If it's bigger than 1, if B is bigger than 1, it's going to be growth. If B is less than 1, it's going to be decay. So 0.8 is less than 1, so it's decay, right? So question A, I'll put A, B, C, and D here. Question A, which is right here, it's decay. All right, question B. If we didn't know it was decay, the second question, what's the rate of decay for this function? So they're kind of giving it away in the second question, right? But again, if that verifies, hey, look, it said decay, that's right, so we're good. All right, so part B. What is the rate of decay for this function? All right, so when I'm looking at whether it's growth or decay, once I've established what it is, I want to change that number in the problem to a percent. So 0.8 as a decimal is the same as what as a percent? 80%. Okay, how is that compared to 100? How is 80 compared to 100? How would you compare? Give me subtraction, addition, fact. If I'm at 100, I get to 80. What did I do? Subtracted 20. So 80% of the previous means there's a 20% decay rate. If you look at the B value as a percent and just ask yourself, how is that related to 100? Plus or minus what? So it's 20% less than 100, which means it's a 20% decay rate. So again, whatever is being raised to the power, write it as a percent, and then ask yourself, how is that related to 100? If it's bigger than 100, it's a growth of that amount. If it's less than 100, it's a decay of that amount. Okay, part C. Running out of highlighter colors here. Let's go with what does it mean? All right. I didn't write this question. I copied out of the book. In my opinion, the book's asking, what does the rate of decay mean? Okay, so each year, the value of the car drops 20%. That's what it means. So the decay rate is how much you're going down by. It's not how much the car is worth, it's how much you're losing in money each year. So what does the decay rate mean? Each year, the value of the car decreases by 20% of the previous year. All right. Now, be careful with that idea. It's not 20%, another 20, another 20. No, it's not like 5 years you lose 100% of the value. It's 20% of 24,000. That's $4,800. So now your car's worth $19,200. Now it's 20% of 19,200, which is something. So each time you're 20% of the previous year, not 20% of 24,000 every time. All right. Finally, when will the value of the car be about $5,000? Question B. Now you guys don't have the mathematical skill yet to solve this equation using normal solving technique. That uses logarithms. We're going to learn that later this week. All right. But for right now, this is a guess and check problem. You guess and see if it's right. If it's right, great. If it's wrong, then try again. Okay, so first person I'm going to ask is, let's go with Colton. Predict. You're probably going to be wrong. That's part of guess and check, is being wrong. Just be happy with the fact that you're going to guess something that's probably wrong, but it's going to lead us to the right answer. How many years do you think it's going to take to be $5,000?
To get down to 5,000?
Yeah, starting at 24,000, we're losing 20% a year. Just give me a number quick. Just don't even think about it.
6 years.
You think 6 years? Okay.
So actually 7.
You want to do 7? All right, 7 years.
I like the number 7.
7.
7's a lucky number. That's my favorite number.
So I'm going to go with 6 first, because you said 6 first, and then we'll use that in case. All right, so 24 times 0.8 to the 6th power. Okay, we're letting x equal 6 years to find out how much the car is worth. If we want the car to be worth $5,000, what should y equal? 5, right? Because again, $24,000, this is in thousands of dollars, so we want y to equal 5, so it's $5,000. So if I hit equals, it equals 6.29. So in 6 years, it's worth $6,291. Yes?
That's close.
Okay, do 7.
All right, very good. Sydney, that's a good guess, Sydney. Anyway,
Well, it's
I know. I'm just giving you. So, but again, that's the whole idea of guess and check. You guess an answer, it might be right, it might be wrong, but if it's wrong, it leads you to the right answer. So we know it's dropping in price. It's still $6,000 after 6 years, so it has to be more than 6 years. So if I go 24 times 0.8 to the 7th power, it comes out to just over $5,000. And again, about 5,000 is what we're looking for, so not exactly. So I would be happy to say that after 7 years. So for part D, x equals 7 years. When we get to chapter 6-3, when we're doing logarithms, we would solve this equation using logarithms. The exact amount of time it would be to get, oh, I did 27 instead of 24. The exact amount of time it would take to get down to, oh, I'm getting $7,000. Try one more time. There we go. It would take 7.0296 years to drop to exactly $5,000. So we'd have the ability using logarithms to solve this, but again, you haven't learned how to do that yet. So for now, a guess and check technique will be sufficient. Just understand what the equation represents. You're guessing this to get that. All right? If they tell you x, you can find y, but if they're telling you y, you can't find x and accept a guess and check at this point. So apply that idea for now. After the logarithm chapter, I'll expect you to solve it by hand and use a calculator to calculate the things that are hard to calculate.